We're joined today by Asaf Yigal, co-founder and VP of Product at Logzio. We'll also hear from Kyoto Tamura, our VP of Marketing at Treasure Data. So before we dive in, let's take a few seconds to review what we'll be talking about today. First of all, we're going to hear from Asaf. What is Logzio? He's going to talk to us a little bit about that. He's going to tell us also about the ELK stack. I'm going to talk to you a little bit about who is Treasure Data and what we do. And we're going to look at machine learning, a little introduction to machine learning, and also as it applies to various business problems. We're going to look at DevOps versus data science quandary. And we're going to look at how most people solve these problems. We're going to see that often the solution involves having separate disjointed systems and losing insight as a result. We're going to look at propose a better way to solve some of these problems. We're going to say we posit that to become proactive, machine learning traced on historical data can help you. And last but not least, we're going to jump into a demo, and we have a little call to action for you. So Asaf, can you talk to us a little bit about what is Logzio and what do you offer?
Well, thank you very much, John. My name is Asaf, and I'm the VP of Product for Logzio. Logzio is running an enterprise-grade version of ELK. And with that, I would like to explain a little bit about what is the ELK stack. ELK stack is made out of three different components: logstash, which is streaming, data ingestion, the time normalization, transition of the data, and enhancement of it, as well as field extraction. The middle component, which is the main component of all of it, is Elasticsearch, which is highly scalable, NoSQL database. And the last component, which is the K, which is Kibana, is a visualization layer that allows you to build visualization, perform searches on Elasticsearch, build your dashboard, and so forth. The biggest advantages of the ELK stack is that it's simple and beautiful. So if you've had the experience of using Kibana or using Elasticsearch, you know that it works very fast. And the visualization and graphs that can be generated using Kibana are actually pretty good. It is an open source, which means that you can download it. It's free to use. You don't need to pay for it, and you can set up the whole stack on your own. And it is very fast. It's very, very fast. The way the data is being indexed into Elasticsearch is fast. Also, the way the data is being retrieved is also fast. This is why ELK is right now the most common log analytic platform that's being used in the world, with quite a lot of developers that's supporting the community, that's supporting the development of it, and adding features all the time. The negative side of ELK is that it's not production ready. We're basically taking three different components, and even though they're being handled by the same company, there are three different components that you have to put them together. So getting it to be production ready is taking a lot of time, as well as the way to ingest data into it. Elasticsearch is a very scalable NoSQL database, but it's not trivial to scale it. You need to have a lot of internal knowledge about how Elasticsearch works and how to build a cluster of Elasticsearch in a way that it's going to be highly available, it's going to be scalable, that no data is going to be lost. So scaling the Elasticsearch cluster is relatively difficult. And the last thing is that it comes with poor security. So right out of the box, it has three open source components. You set them up. It has no authentication, no security into it, and you are responsible to do all the work. It doesn't have any role-based access and stuff like that. So to make long story short, the ELK is really, really great to use, but it is not production ready. It's not an enterprise grade. And if you do want to use it in an enterprise environment, you would have to complement it, and you would have to build a lot of stuff around it. Logzio provides an enterprise-grade ELK. So we're taking all the advantages that you get with the open source ELK, and we are providing additional service. So first of all, we provide it as a cloud service, which means that you sign up on the web, you send your logs, and that's all you need to do. You don't need to install anything. You don't need to scale anything. You don't have to have any knowledge about how to set it up. All you need to do is register and start shipping logs. So it's basically up and running within minutes. We have quite a lot of customers that set it up and send logs within 2 or 3 minutes. We already have dashboards up and running. For us, this is infinitely scalable, so we don't care if you send 10 gigabytes a day or you send 1 terabyte a day. The system is completely transparent to the user. and you can send as much data as you want. You can send as little data as you want. It's completely up to you how much data you send. You are relieved of the obligation to figure out how to build a cluster to be able to support such data. We're doing everything for you. It is production ready, so we monitor it all the time and we run it all the time, and we make sure that it is running all the time and that it is production ready for you. We've also added a few features to it that are enterprise grade features, like for example alerts. Alerts are not part of the open source ELK, but we have added it into the cloud offering that we have. So we have a unique alerting mechanism. You can define whatever query you want in Elasticsearch. It's also integrated into Kibana, so all the visualization, everything can be controlled through Kibana, and you can set up alerts directly from Kibana. We've added advanced security, so while we provided 360-degree security, we provide role-based access, multi-level security, meaning that both on the data ingestion, both on the data searches and the visualization, and everything is completely surrounded and secure and encrypted. It is also highly available. We have a few tiers of backup and recovery that we do along the way. We have quite a complicated log ingestion path that also include logstash, but also include other components in the middle. And we provide high availability, meaning that, first of all, no logs are being left behind. We always ingest all the logs, and we also make sure that the system is up and running 24/7, and you're not going to be losing data, whether it's upgrade, whether it's changes to configuration of Elasticsearch, changes to configuration of Logstash or Kibana. We assure you that it is highly available. So, again, to make a long story short, we provide an enterprise-grade ELK as a cloud service, which gives you all the benefit of using the ELK stack, but you don't have to do the hard work of setting it up on your own and maintaining it all the time.
All right, thank you, Asaf. So let's have a few words about who we are at Treasure Data. So we're a data analytics pipeline in the cloud company. We ingest and we store your data. We provide a cloud-based analytics tools, including data connectors to a wide and ever-growing range of sources. We also have query tools like Hive and Presto, which you can use on your data straight away. And we have result export functionality to send your data to nearly any system, visualization, data storage, machine learning of your choice. So we're based in Silicon Valley, California, as well as Tokyo, Japan. And we started out with the open source tools mbulk, which is a bulk loading tool, and Fluentd, which is the unified logging layer. You're going to see a little bit of Fluentd demo today, actually. We process currently Twitter's load times 100 events per second. So why do we exist? Well, businesses need analytics to improve products and services. Building analytics infrastructure is actually quite hard. It requires a lot of time, money, and people. To build out an analytics pipeline, you need developer competence. So how do I instrument my applications to send events? You need data science and business intelligence competence. So what intelligence or insight do I want to gain? What events do I want to measure, analyze, and collect? You need DevOps and infrastructure competence. So how will I build my analytics pipeline? What trade-offs am I willing to make around the timing of my data, latency, maintenance overhead, and etc.? Of course, you also need managerial competence. So how will all of this affect my resources and bottom line? Of course, using a cloud-based solution like ours won't eliminate the need for these, but using a pre-built data analytics pipeline in the cloud might make things easier. So let's speak to a few words about Machine Learning 101 for DevOps. Well, DevOps is all about automation. We need to ensure that processes run, that outputs can be automatically verified, and so forth. The reason you would need machine learning is to add more intelligence to that automation. For example, we used to set arbitrary thresholds of what an outlier is. However, with machine learning, you can train your system to learn what an outlier is. And let's talk a little bit about outlier factors because we're going to touch on this in our demo. So the local outlier factor is a concept. It's based on a concept of local density, where our local density is given by k nearest neighbors, whose distance is used to estimate the density. By comparing the local density of an object to the local densities of its neighbors, one can identify regions of similar density. along with points in a regions that have lower density than their neighbors. These points are considered to be outliers. And let me clarify that a little bit. The local density is estimated by the typical distance at which a point can be reached from its neighbors. In other words, if a point in a cluster exceeds the typical distance to other points, it's an outlier. Local density is a definable threshold, as we will see later in our demo. Let's look at some problems. One of our problems is log data. So log data is typically used in a limited fashion. Because log data is typically inconsistently accessed and consumed, log data is generally used to identify hidden and ongoing problems in an ad hoc manner. However, by analyzing historical data in treasure data and using that to complement your real-time systems, including your ELK stack, you can surface deeper insights into your system. So let's see how this applies to some business problems. What if I wanted to detect abusive users and automatically block them? To do this, I would study behavior and access patterns of normal users, then train my system to look for outlying behaviors, in addition to obviously threatening ones. Stated more simply, you only know what you need to look for. Visualizing data without intelligence, or machine learning if you will, means you are trying to make sense out of noise. Another business problem relates to correlating multiple metrics that have otherwise hard to correlate. The problem is easy to grasp when you consider you must look at an entire pool of data, often in disparate systems or pipelines, and then be able to spot correlations. Relative cyclical correlation isn't easily trackable with either machine learning or a system in which to analyze both historical and real-time data. So there's a few DevOps problems that are also related to the problem of disjointed systems. One problem also affects the unity of effort amongst teams. So currently we have two separate disjointed systems, our data scientists and our data engineers. Our ops team typically lives in the ELK stack, and our data scientists often will work in different systems that are not integrated. Another problem that's kind of related to that, of course, is that organizations have DevOps, but not data scientists. Some orgs are looking to do data science but don't know where to start without first hiring one. So what would a solution look like? Well, let's present an example of the sort of system we're proposing. Some of the requirements for that system would be, well, you want your system to implement machine learning to handle very large data sets. This would enable you to do relative cyclical correlation across those data sets. You want a system that can analyze both historical and real-time data. You also want a system that unifies your data pipeline from DevOps but also integrates with what your data scientists are doing. And finally, you want a system that leverages existing competencies. So here's an example of the sort of system that we propose. At stage 1, we're ingesting data from, for example, syslogs, web, nginx, and S3. At stage 2, we're connecting to our pipeline via data connectors, our SDKs, our bulk loaders, and a tributary instance of Fluentd. At stages 3 and 4, things get quite interesting. An aggregate instance of Fluentd routes the data to Elasticsearch for fast, high latency real-time queries, as well as to treasure data for lower latency access to historical data. What's more, treasure data can apply machine learning algorithms to the data it consumes to bring out insights, like outlier analysis, which we saw earlier. Logzio can consume data from both sources. Finally, at stage 5, our processed data can be sent off to third-party sources for, among other things, advanced analytics, reporting, data stores for other teams, as well as visualization. In the ELK stack, which is Elasticsearch, Logzio, and Kibana, Kibana is used for visualization. To bring in better, previously undiscovered insights to log analysis, use Logzio plus treasure data so that machine learning and advanced analytics-based insights can be immediately shared on Logzio alongside other metrics. This brings better, more profound insights from the comfort of a familiar tool. So what would the outcome of this real solution be? Well, we'd have a much more intelligent system with a reduced number of instances. We would increase system availability, etc. By combining the two, we are bringing the data science tools to the DevOps teams to leverage the power of both, and we can leverage both data science and DevOps. So we're going to get into a demo, and I'm going to explain a little bit before we jump in. We've been sending traffic through our system via a Fluentd plugin. The goal of our analysis today is to identify if any of these runs are outliers. We are running traffic through Fluentd to our Nginx logs, which Fluentd then picks up and routes to treasure data as well as to our ELK stack. To do this, we have been running a series of queries that collect, clean, and normalize the data before running the final algorithm. Lastly, we set a moderate threshold to identify the outliers. If we were to put this into production, we would want to set a more flexible threshold, perhaps in a higher percentile, so that the context of the outlier will change as the data changes. The first thing that is done is to vectorize the data for feeding into the algorithm. This is purely the format that the algorithm needs the data in. Then we normalize those vectors. The algorithm then takes each point and calculates the distance between it and every other point. With these pairwise distances, we are then able to build a nearest neighbor matrix, and from this matrix we are able to calculate the density for each point. The lower the density, the more likely that point is to be an outlier. Our last step in such analysis would be to decide how low is too low, and therefore an outlier. You could set a static threshold, as we have done here for simplicity reasons. However, a more robust approach would be to set a dynamic threshold that changes relative to the data. And with that, I'll be handing the mic over to Kyoto Tamura, our demo expert, to run the demo.
All right, so as introduced by John Hammock, I'm Kyoto Tamura. I used to be one of the main maintainers for Fluentd. So like the place we're going to start is actually on the server that is running Fluentd. And I trust that many of you have heard of Fluentd, but many of you probably have not used it. So I'll walk you through a quick example of how Fluentd works. All right, so I'm logged into the machine. So this machine is running Fluentd, and I am using a version of Fluentd called TD Agent. As the name suggests, this is a packaged version of Fluentd with all the plugins QA'd, and that is what I'm using. So if I run pxx, grep for the name, you'll see two processes. One is a supervisor, and the other is the actual Fluentd that is running. So let's take a quick look at the config file before we actually look at Logzio ELK stack app. So I would look at the file. It's located under etc TD agent, and I'll walk you through line by line here. So everything starts with inputs, and in Fluentd's configuration, inputs are defined in the directive source. So here's one input that we will actually use to feed the result of the machine learning batch calculation. So the second line says that type tail, so it's going to tail a log file. The format's going to be CSV. You can define your own keys, and you can also configure which column is going to be processed as a time field. Also, another data source, input source, is type forward. And what I'm doing here, as I'll show you later, is I have this generator script for the incoming traffic load, and that is using the forward plugin to have the data fed into Fluentd. And in real life, most likely you'll be collecting data from like syslog, you'll be collecting data from files, and if you're into like Kafka and that kind of message queue, you can also dequeue data from message queues. There are about, I think, 100 input plugins with various parser plugins. So if you have custom log files with multi-lines or complex regular expressions, those are all supported out of the box as well. So once the data is fed into Fluentd, you can optionally filter the data. For this simple demo, I'm not filtering, and I'm actually sending all the data into one destination, and that is marked here. So the match directive actually defines and creates the outputs. And here we're using this feature called copy, which tells Fluentd to copy the data streams. And for each copy of the stream is sent to different backends. So one backend here is being sent to Logzio using our buffering. And the folks over at Logzio actually wrote 2 versions of the plugin so that one version actually buffers the data and the other version doesn't buffer the data. We're using the buffered version to ensure that no log message is being lost. And you can see the configuration parameters. As you can see, the buffer will be in this directory and it flushes every 5 seconds. This is, of course, configurable like all other config parameters. And also, for the purpose of batch machine learning calculations and more advanced analytics, we are sending the data to treasure data. And there's an API key. And if you're security conscious, you can actually use the environment variable so that it doesn't appear in the config file. I just wrote it in here for the ease of use. And again, you can also buffer your output so that should the connection between your server and treasure data or Logzio break, your data and payload will be buffered so that in the subsequent retries, you'll be able to put the data into treasure data. One advanced and very useful concept that I skipped, which I'm going to cover now, is this notion of tags. So when you're actually starting to do more advanced log analysis, invariably you're going to collect data from many data sources and send it to many data outputs, which means the process of managing different data streams can become fairly complex, and if not done right, unmanageable. The way we address it inside Fluentd is using something called tags. So each message that comes into Fluentd, whether at the data source or by Fluentd, it begets this property called tag. So as you can see in this example, when it's tailing this particular file, we're assigning it the tag logzio.anomalies. For this other data source, it's actually the event producer that is giving it a specific tag. So once the tag is assigned, Fluentd is smart enough to match it against different outputs and filters. So here, what this match tag says is that I'm going to match all the events whose tag starts with the logzio and has a subsequent part and one part. So if you actually wanted to match all the events that just starts with the prefix logzio, as I just did, you can just add another asterisk so that it is arbitrarily length wildcard. But let's go back. So this is already running, and you can see that by looking at the usual service command. Okay, so TD agent is running. So let's hop over to Logzio. And for those who do not know what Logzio is, as Asaf said, it's a fully managed ELK stack app that is in enterprise and production grade. So as you can see already, inside the Discovery tab, you can see all these events that are being generated and sent over to Logzio through Fluentd. And here you see the timestamp and messages, and there's no message because my event is dummy events and I didn't configure messages. But you can look at some other fields such as the size of the payload or the time it took to process the request. And when you look at those events, like you can sort of eyeball like, hey, maybe the request time is going up, or maybe the size of the payload is not being consistent, or maybe you do a deploy and some of these parameters change, you'll be able to eyeball the changes. But as you start to look into more complex anomalies, such as maybe there are events whose size is small, but the request time is taking for a while, or the other way around. Maybe there's something iffy going on in the app. Well, like those can be noticed, like if you actually have the right visualization. But all of us are sort of used to this idea of looking everything as a time series. And when you have a time series data, it's kind of hard to see the correlation between different graphs. So what I'm going to do, or what I've done, is I actually use treasure data to do the more advanced part of this. And what you're seeing now is actually treasure data's web app. And just like Logzio, we're fully managed, no installation required, and it is a web app that you can just log into. So let me go over to the databases tab, and there's a Logzio database. And as you can see, it just updated, but the data is being streamed into the table called sample nginx. And as you can see, as a timestamp, account ID, those are fake, by the way, request time, user agents, and size. And this is admittedly a small portion of the data that you'll be getting from Nginx and similar web servers. One thing to point is that we're schema on read, meaning that you can actually send any JSON as long as it's timestamp. If it doesn't, we actually add it for you. And the schema can change, which happens a lot if you're, for example, reconfiguring web servers or adding new events in your web apps or like mobile apps. And all this data is streamed in without any kind of hiccup when the schema change happens. And you can retroactively edit and rename the fields so that the analyst would be happy as well. So what I'm going to do now, or what I already did, is the actual local outlier factor calculation that John talked about takes a little while to run. So this was like the wrong one. But there was a query that I already ran. And Treasure Data has this nice command line tool that downloads the result of the anomaly detection calculation. And through Fluentd, I fed it back into Logzio. And that was the first section of the config file that you saw. So now, if I go to the dashboard here, then I have the dashboard for anomalies. And as you can see, a while back there was a couple of anomalous events. And now you can go back and retroactively see what was actually going on there. So here what we're detecting is those are the count of the events that was outliers compared to the rest of the events when you're looking at two variables, the request time and the size of the payload. So you can go back here and maybe there is a push, maybe there is some kind of change in some of the servers, but this is a very good first step to triage what's going on in your systems. The cool thing about this is twofold. One is this did not require any specialized skills in data science. Sure, like to use Treasure Data, you would need to know a bit of SQL, but once you have the queries written, it's very easy to run it with regular intervals and have this data fed back into your real-time monitoring system, such as Logzio. And now I'm totally like relying on Logzio's like cool features, but for example, you can set up an alert that would run every 5 minutes, and if it sees any outlier, then it would send an email to the person who should be aware of this. And this is essentially the whole point of bringing data science or data scientific approach into DevOps. Because frankly, in many organizations, DevOps is the place where all the data is generated. And if we can apply a little bit of statistical learning and data science to that data set, there's a lot of things that you can do to vastly improve how your operations and services are run. So with that, I will pass the microphone back to my coworker.
Great. Thank you very much, Kyoto, for the demo. So whatever you do, you want to be able to focus on analytics and not infrastructure. We can have a quick look at some of the integrations that we do, and this will show you some of the technologies we integrate for with data collection. I mean, obviously starting with Fluentd, JavaScript, Google Tag Manager, Segment IO. We integrate with a range of data marts. This, again, is only a list of some of them, but it includes MySQL, Postgres. We've done quite a bit of work with RDS and Redshift already, including previous webinars. Cloud services such as Salesforce, S3, and Heroku. Digital marketing tools. We have business intelligence integrations, including Tableau, Pandaho, obviously Logzio as well, a number of programming languages, and even ETL and workflow tools such as Luigi and Informatica. HiveMall is the machine learning library that we use. And there's additional integrations as well. So always a good thing to take a look and see what's possible to do, what's possible to add to your ELK stack, and to your compatibility with your other tools as well. So to bring in better previously undiscovered insights to log analysis, we propose you use Logzio plus treasure data so that machine learning and advanced analytics-based insights can be immediately shared on Logzio alongside other metrics. This will bring you better, more profound insights from the comfort of a familiar tool. You can reach out to us at Treasure Data at sales@treasuredata.com. Our Twitter is below. And also, you can reach out to Logzio directly to ask about any of these integrations at sales@logzio. Logzio Twitter is there as well. So with that, I'd like to thank you for your time. And we are now opening up the line to questions.
Thank you, John. Thank you, Asaf. First question looks like it is for Asaf. Can this solution be bundled together as a single package?
Thanks for the question, John. And yeah, the question is yes. I mean, we can work with the customer, whoever want to do it, and make sure to set up the solution in a bundle package where the same configuration that Kyoto shows, where you send the data both to treasure data into Logzio and be able to forward all the anomalies back to Logzio and be able to display everything on the same graph as well as create alerts and get the visualization in one place.
All right, thank you, Asaf. Next one for John at Treasure Data. So what if one of the data connectors isn't implemented, I guess it's input or output with Treasure Data already?
So since we have a plug-and-play architecture with our data connectors, if we don't have it already built out, we're more than happy to build one out for you. So just reach out to us and ask what you need to connect with, and we can do that for you.
All right. Next one's for Asaf. What if the customer wants to use their own ELK stack?
So yeah, I mean, first of all, it's absolutely possible to use the same configuration and send it to their own ELK stack. There are features, enterprise-grade features that would be missing, but I think that you can use the same Fluentd configuration to push data into your own Elasticsearch and run Kibana on top of it. So what we have today is the best replication of the whole ELK stack.
All right. And let's see. Last question looks to be for both. Can you describe what your implementation services look like? So I mean, I guess, after you buy the service, what do the next steps look like? What type of help is offered to implement the services?
At Treasure Data, we have a full range of support to get you up and running. So if you go to Treasure Data Console, there's a chat available there, and one of us can basically work through the integration with you. Of course, every integration is different, so it's going to have kind of variable number of steps or things you might need to do, but we can certainly help you through it.
All right, and Asaf, same question to you. So I guess after someone buys, what sort of implementation services does Logzio offer?
Yeah, so we're offering implementation and onboarding services that include like dashboard building and visualization, setting up alerts based on kind of best practices, something that we do. We also offer support through phone and through chat, and we're going to roll out pretty soon kind of like a forum support and a knowledge base so people can be self-service as well.
All right. Excellent. That looks to be all of the questions that we have right now. We'd like to thank everyone for joining us today. We did record this session, and we will be putting it up on YouTube as soon as we can. I want to thank John and thank Asaf for their time today. And stay tuned. Follow Treasure Data at Treasure Data. Follow Logzio at Logzio. And we'd love to hear more from you. All right, everybody. Have a great day.
Thank you.